All right. Hello, everybody. Bittersweet. We are almost to the end of our Python experience this semester. So, last video, we went through and did the chi-squared test for my two variables, whether you wear eyeglasses and whether you've been diagnosed with asthma. And we had really just huge p-value. No significant difference at all. You can see it in the mosaic plot, but really without the p-value, you're not sure. Oh, we're sure now. We have to fail to reject the null hypothesis, which isn't the end of the world, but it is what it is. But some of you will have significant p-values. If it's less than 0.05, you have significance. And when you have significance, p-value less than 0.05, and your explanatory variable has more than two categories in it. Mine has four. When that's the case, you have to do a post hoc, just like we had to do with our f-test with ANOVA, right? So we had to see which out of the different categories did that difference come from. And here's the post hoc, the two key. Well, we're going to do something similar this time. It's going to be a bit more involved. It's not going to just be a one block of code to get which things have a significant difference. And it's not Tukey this time. It's called Bonferoni. And so what I've done is I've gone back into the code book and come up with another couple of variables which I was pretty sure would have an association. And so what I chose were H4 MH2, which is how isolated, how often do you feel isolated? And so never, rarely, sometimes, and often were the different levels for that. And I went ahead and I data managed it, and then I put in the formatting, and so I've got this new variable isolated for that one. And then H4MH8 is how attractive you think you are. And so I thought that there would be an association. I'd figured that folks who felt isolated a lot partly felt isolated because they didn't think they were attractive. Whether other people think they're attractive or not, if you don't think you're attractive, you might want to isolate yourself, right? That's just kind of human nature. So that's what I was figuring. And I went through and I did the data management also with attractive. And then what I did, because I wanted this to be the response variable, is I collapsed it, and I tried this out, and I thought it might work. Instead of collapsing by doing these replace thingies in here, I collapsed it with my formatting code. So anyone that was thought they were very attractive or moderately attractive, I categorized them as attractive, and anybody slightly attractive or not attractive, the way they thought about themselves, I categorized as they thought they were not attractive. And so I got those two levels which you need to have for the response variable. And so here we go. Here's our table that shows that it did that. So now I'm going to start the whole series of stuff for the chi-squared. So I did the little table, and it really looked like the percentages were different. Remember, if there's no association at all, even in the sample, then all of these percentages going down here would be 68.1, and all of these percentages going down here would be 31.9. And they're not. There's quite a bit of difference, 27 versus 42.8, right? So those are pretty darn different. So it seems on the surface, at least, that I was correct. But let's look at a couple of graphs. Here's the stacked bar graph. Yeah, looks like the percentages within each category is different. Or the proportions, if I'm going to use the word that statisticians use. And then I looked at my mosaic plot, and this is, like I can really see down here different from up there. And then I go ahead and do my chi-square test, and I get my chi-square value of 45. Remember, it was 2? So when you added up all the square differences divided by the blah, 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 when you do that calculation, you get all the way up to 45. Um, and our p-value needs exponential scientific notation, right? So e minus 10 means times 10 to the negative 10, which means move the decimal plates over 10 decimals to the left. 0.0007657, blah, blah, blah. Right? So definitely we got some significance here. So just like we did with the Tukey, we are going to try to figure out, well, which pairs are significantly different. Like I can guess that never is significantly different from often, because look at how different these percentages proportions are. But without doing the test, you can't be sure. And one thing that with Tukey is they gave us this true false thing where let's see if I can find it. Yeah, so where we knew which ones had significant differences because we rejected them and they told us to reject them. Well, that's so easy with this. We have to come up with that adjusted alpha. And so our adjusted alpha is the 0.05 divided by how many different pairs you can make out of these 4 items. So yeah, you can see the camera over there. And I'm not flipping you off, I'm just counting. Never with rarely, never with often, never with sometimes. So I've just paired never with all these other 3 things, and I got 3 things already. But I haven't paired rarely with often yet, and I haven't paired rarely with sometimes yet. And then finally I have to pair often with sometimes. So there's 6 different ways I could make pairs that are a different pair from another pair. And so I have to make a little chi-square test for each of those pairs. So it's not too bad. It's a lot of copying and pasting. But let's go through it. So I've done most of them. Here I'm comparing never with rarely. Here I'm comparing never with often. Here I'm comparing never with sometimes. There's the first 3. Then I should compare rarely with sometimes and often with sometimes. Rarely with sometimes and often with sometimes. Let me move these into order. And then finally I have to do often with sometimes, and I don't have that yet. So what I'm going to do is try to explain what these things are doing by making this last one by copying and pasting and adjusting. So the first thing is I like to have this comment code that explains which 2 I'm doing and which ones am I doing. I'm doing often with sometimes. All right, so often with sometimes. And that's category 3 together with category 4. And honestly, these are numbered wrong. I should go back and number these correctly. I got kind of confused when I did this before, to be perfectly honest. Who can blame me? This is a little bit confusing. But we'll go through that and try to find the error in this video as well. We're already at 9 minutes, but what the heck? You're getting used to watching these crazy videos. Okay, what I'm doing is I'm setting up a way so that I can make kind of a subset of my isolated variable that only has the 2 categories I'm working with. And the ones I'm working with is often and sometimes. So I'm going to put often first. Have that come first. And then not rarely, but I want sometimes over here for the second grouping. And I'm not going to go through the details. I barely understand it myself. for why you have to list this twice and put a colon in between it. So it's curly brace. We haven't used a curly brace before. So recode 3.4, where I'm going to compare category 3 with category 4. I'm going to make a whole new variable that only has category 3 and category 4 in it. It's only going to have often and sometimes. And I'm going to do that by mapping with this recode thing that I just created. So I need to make that be recode 3.4. And then I'm going to make the table 3.4, doing a normal crosstab, but using this new thing that only has those two categories. It kind of just throws away the other categories, all the data and all the everything. It just throws it away. Almost like you're data managing and nanning, but it, I don't know. This is somehow better. It's what was 3.4, what was suggested by those folks I'm trying to learn this from. And then finally 3.4. Okay, so to summarize what I've done here, I'm doing this comparison with category 3 together with category 4. Not that they were coded originally in the code book as 3 and 4. It's just looking at here, this is the third category and this is the fourth category. So everything is 3.4, often with sometimes. And so I have to make some name for this thing that I'm going to put inside the map function. And I just call it recode 3.4. I put the names of those categories twice in quotes, separated by colons, then a comma, then the names of the other category twice, each in its own quotes, separated by some colon. I think I said semicolon. It's a colon. And then I'm making up a new variable using this map function, passing in this recode 34 into that map function. And then I do one of these crosstabs and chi-square tests using this comp 3.4. So I make the table 3.4 that I pass into the chi-square. And when I do all of that, it gets me a p-value. Now, is that p-value small enough? It's certainly smaller than 0.05. But does that mean that there's a significant difference between these two? I don't know yet. I have to do a little bit of math. So I could go to another calculator, but Python is a freaking computer programming language. It can do calculations. So what I need to do is 0.05 divided by how many of these different pairs I had. And so in this case, it's 6. And if I run this, it tells me I need 0.0083. That's how small this p-value has to be. So that's pretty small, but it's not small enough for these to be significantly different. So let me go and run the other ones, and I'll go in backwards order because I'll fix this as I go. And it's okay, I'm going in backwards order, just so you know, because I'm not changing isolated in any of this stuff, and I'm not changing attractive in any of this stuff. I'm creating these new things. Based off of this stuff I'm not changing. So it's okay that I'm kind of doing it out of order. It's not going to affect anything. Okay, so this was supposed to be category 2 with category 4. That's what, let's see, rarely with often. Is that right? Yeah. Did I have it right in the first place? I think I had it right in the first place. Oh God, now I'm like really confused. All right, let's just go through all these one by one in order. Make sure they're in order. Make sure they're saying what they're supposed to say. So I'm trying to do never with rarely. This first category with this second category. Never with rarely. Never, rarely. First category, second category. Is there a significant difference? Maybe. Has to be p-value less than 0.008. P-value. Oh yeah. Oh yeah. 5 decimal place moves. Point oh 0.0000558 is less than 0.0083. So we have significance between those two categories. How about the next one? Never with often. Category 1 with category 3. Never with often. Do we have significance? Yeah, even more so, which makes sense because this is lower even than this one. So this is significantly different from this one. Okay, cool. Never and often are significantly different percentage of folks that think they're attractive. Um, the next one is never with sometimes, 1 with 4. Never with sometimes, 1 with 4. I love it. Significant. Totally significant. And hard to see why these two are so much more significant. It was minus -0.07 versus minus -0.05, but it's partly to do with how many are in the categories. So since this is a smaller category, that's part of why um, I think that there's more significance, not just that it's a little bit lower. But in any case, these are significantly different. So next, because we've compared never with everybody, next we're going to do rarely with often, 2 with 3. So rarely with often, 2 with 3. Yep. Okay, cool. Do we have significance? Ooh, do we have significance? Let me check again. 0.0083, yes. 0.00295 is less than 0.0083. We have significant difference between category 2 and category 3. Okay, so that one's good. Next, we have to do category 2 with category 4, rarely with sometimes, 2 with 4. Love it. Do we have significance? Hell no. Sorry to say the H word, but no. P-value of 0.2 is not even less than 0.05, let alone less than 0.0083. So no good, no significance. And then we did this one already, 3 with 4. Okay, we did them all. Awesome sauce. Have a good day. Almost 20 minutes. So sorry, but there's how you do Bonferoni.